Good afternoon everyone, we are group number 3. Our project is BeeBuzz Smart Beehive Monitoring Device. So this is our outline, introduction, aims and objectives, project flow, device prototype, demonstration, and finally commercialization and future works. Today I am excited to introduce you an innovative solution that is set to revolutionize the world of beekeeping. BeeBuzz, the Smart Beehive Monitoring Device. As you may know, beekeeping is one of the most traditional agricultural fields in the world. Honey production happens according to a natural cycle inside the beehive, where temperature, relative humidity, and weight are major factors that affect the honey production. However, monitoring these factors physically and frequently can be expensive and time consuming for beekeepers. This is where BeeBuzz comes in. It is an innovative solution that monitors the real-time condition in a beehive using an embedded device that displays the data through a mobile application and notifies the beekeeper about sudden changes. This remote monitoring through an internet is more beneficial than physical monitoring in several ways. BeeBuzz is an IoT embedded solution that significantly reduces colony losses and increases productivity. By changing the way beehives are monitored, BeeBuzz enables easier maintenance and cost reduction for beekeepers. The device features temperature and humidity monitoring with alert notifications, weight monitoring with alert notifications, observation of the beehive, lid open or closed with notifications, and detection of beehive box theft with alert notifications. With BeeBuzz, beekeepers can better monitor their hives, reduce colony losses, and increase productivity. This will contribute to more sustainable and efficient honey production, benefiting both beekeepers and broader agricultural industry.
Aims and objectives. Our aim is to provide a platform for beekeepers to monitor their beehives by enabling efficient features and valuable insights regarding apiculture and saving their bees. Objectives. The proposed solution is to use new technology to monitor beehive and provide alerts to beekeepers to help them adopt more sustainable practices. This includes monitoring the temperature and humidity inside the beehive as well as the weight of the beehive. Additionally, the technology can detect if the hive lid is open or closed and send alerts if there is a potential theft. By using monitoring technology, beekeepers can take better care of their beehives and make more informed decisions to promote sustainable beekeeping practices. Project flow. There are 5 project phases. Project idea generation. Brainstorm idea for beekeeping monitoring system that uses new technology to promote sustainable beekeeping practices. Then making the low-level prototype using breadboard. Create a basic prototype of the monitoring system using a breadboard. This will involve testing, refining, and the various sensors and components needed to monitor temperature, humidity, weight, lid status, and the potential theft. Then making the high-level prototype using VeroBoard. Once the low-level prototype is functional, create a more advanced prototype using VeroBoard. This will involve designing and building a more robust circuit that can withstand and conditions of a beehive. Then developing the mobile application. Create a mobile application that can communicate with monitoring system and provide alerts to the beekeeper. This will involve designing a user-friendly interface and integrating the various sensors and notifications. Launching the test device. Test the monitoring system by installing it in a beehive and collecting data over a period of time. Evaluate the data and refine the system as needed. Then, scaling up production. Once the monitoring system has been tested and refined, begin producing and marketing the product to the beekeepers who are interested in adopting sustainable practices. This may involve partnering with beekeeping organizations and provide educating and training on how to use this system effectively.
Okay, now let's move on to the device prototyping part. First of all, we have designed our BeeBuzz device circuit schematic by using the Fritzing software. For this schematic, we have used the breadboard. As you can see here, we have connected the sensors to the Node MCU Wi-Fi module in a proper manner. So after the designing the schematic, we have created that low-level prototype on the breadboard and tested the functionalities by uploading the code base into the Node.mcu Wi-Fi module. In this phase, all the functionalities in our device work properly, so we will move into the next phase after the breadboard testing phase. In this phase, we created our tested device on the Vero board and made the high-level prototype for our BeeBuzz device. So we soldered the female headers into the Vero board, and all the sensors and Wi-Fi modules can be removed from the Vero board anytime. In the next phase, we started developing our mobile app using the Flutter. So this is the screenshot while we doing the coding part for the BeeBuzz mobile app. And this is the fabricating PCB we have designed by using the ECEDA. So you can see here there is a clean and more completed PCB here. So we have also printed our product name and the slogan on the PC board. Unfortunately, we couldn't order this fabricating PCB because of import restriction in the current situation. So this is the 3D view of the fabricating PCB, and you can see here the top layer and also the bottom layer of the fabricating PCB. Okay, so this is the demonstration of our BeeBuzz Beehive Monitoring and Alerting IoT device. So basically, we have used the ESP8266 Wi-Fi module as the microcontroller for this device, and for the sensors, we have used DHT11 temperature and humidity sensor, the HX11 weight sensor, and the HCSR 04 ultrasonic distance sensor. For the prototype, we have soldered these sensors and the microcontroller to a Vero board by using the female headers. And you can see there is a red color LED light powering on the device. If connected power to the device, will connect to the internet through the local area Wi-Fi, which we mentioned in the code base. If it is successfully connected to the Wi-Fi, then the device try to connecting to the Firebase database. When the device will be successfully connecting to the Firebase, the LED on the Vero board is powered on, because we have controlled this LED through the Firebase database. This is the Firebase database that we use for the device. Here you can see the real-time sensor data will be coming from the device into the database. For the demonstration purpose, we are using the cardboard box as the Beehive. You can see here we have attached the BeeBuzz device to the box, and its ultrasonic sensor should be facing into the top of the box. That means to the lid. The weight sensor should be placed under the Beehive box like this video display. Also in this prototyping stage, we use the micro USB cable to power up the device from the laptop. Okay, now we will see the mobile application features and how it works in real time. for the first impression, we have added the nice splash screen into the mobile app startup, and then you can see this on the mobile app home. This is the mobile app home page. So there are 4 data displays on this app: Beehive temperature, humidity, weight, and the Beehive lid status. Okay, now you can see here when I try to change the environment around the DHT11 sensor, the humidity value is increasing from percentage 83 to percentage 84. Also, you can see when the lid is open, the lid status on the mobile app is changed from closed to open. When closed the lid, it will show the lid status as closed. We have included the device details screen for the BeeBuzz app. Here we have basically displays to the user what is BeeBuzz and what are the features the mobile. By using the mobile app, they can try with this device. In these settings, the screen user can set the threshold values to the sensor data alerting system according to their preferences and their Beehive box internal and external environment. By using this feature, this device can use in different areas and different countries. As the video displays, user can change the threshold values using the these control bars and save it automatically update into the Firebase database. Now we can try to check the temperature and the humidity sensor by changing the environmental condition. So after the increasing temperature of the DHT11 sensor, you can see the temperature value gradually increasing and the humidity value is gradually decreasing in the mobile app in real time. Here you can see the current temperature value is 26 Celsius degrees, and now go to the settings and we trying to decreasing temperature threshold value to less than the current temperature value. The user will immediately get the alert notification called temperature spike in your Beehive. Also, you can see the current humidity value is percentage 82, and now go to the settings and we're trying to decrease in the humidity threshold value to less than the current humidity value. The user will immediately get the alert notification called humidity spike in your Beehive. For the lid open or close alerts through the mobile application, we need the distance between the Beehive lid and the ultrasonic sensor. So here you can see there is a 15 centimeters distance between the Beehive lid and the ultrasonic sensor. Now you can see the Beehive box lid is closed, and mobile application status also displays as the lid closes. When we are opening the Beehive box lid, you can see the status of the Beehive box lid on the app immediately changed to the open status, as well as the user will get the alert notification to their mobile phone in real time. When we close the Beehive box lid, app will display the lid status as closed. Also, you can see here the threshold value of the distance between the beehive lid and the ultrasonic sensor, user can change as per their beehive box environment. There is another feature of this BeeBuzz device is the theft alert notification and monitoring the weight of the beehive. So now you can see here there is a weight of 2.3 kilograms, and when I get this item from the box to the outside, the weight sensor value is decreasing. So when the weight sensor value is less than the threshold value, user will get the theft alert notification to their mobile phone.
Commercialization and future works. So let's see strategic plan for commercialization. We select our brand name as BeeBuzz, and here we use Blender software to create the 3D model for our final high-level product. From this mini project, we have finalized the BeeBuzz low-level prototype, and in the next level, we are planning to complete our full product with the use of AIoT. So let's look into our product. BeeBuzz. Save bees and grow your business. From these two images, you can see our final product. Here you can see the worldwide distribution of honeybee production and our target markets USA, Europe and Australia. As you can see, the largest percentage of worldwide farmers are home-based, and we selected as our target market.
So let's move on to the potential for the research publication. So beehive monitoring is one of the trending research topic in IoT field, and there are so many research articles about this topic available on the internet. And bee farmers need to consider so many things when they are entering to the bee farming: colonizers, protecting the queen bees, save bees from the wasps attacking. So the device is built because of this, and we are planning to adding more unique features into BeeBuzz device and designing our own circuits semestic by using microcontroller like ATmega328P and ISP32 like microcontroller. And also in the future plans, we are planning to improve this low-level IoT prototype into high-level AIoT products. And after the implementation of future work, we will be planning to claim intellectual property right to our BeeBuzz IoT product in the future steps. So let's move to our future works. So transforming this IoT device into AIoT device and importing the fabricating PCB via PCB manufacturers and printing our own BeeBuzz device enclosed by using the 3D printer and creating the decision making system for the farmers to better productivity of the beer and updating the mobile app also in our future work. So upgrading the single device into multiple device usage by is the other future work, and get the intellectual property rights and install sensor data at least about 6 months and display graphical chart in a mobile application for farmers as a future reference, and creating the bee health prediction via mobile app also is in our future works. So that is all about our presentation. So this is our team members. So thank you very much.